Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. Today topic is light reflection and refraction chapter. Light reflection and refraction chapter. Light, light reflection and refraction. Refraction. So here, light is a form of energy which gives the sensation of sight. Light is a form of energy which gives sensation of sight. So when light is incidenting on the surface, so I'm taking here, this is a plane mirror. So I'm considering this a plane mirror. Plane mirror. Okay. So here the light which is incidenting on the surface is called incident ray. The light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. Incident ray, reflected ray, and the line which is perpendicular to the plane surface, that is called normal line. The line which is perpendicular to the plane surface, that is called normal line. So I am taking here the angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. And angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. Angle between incident ray and normal line is called angle of incident. Angle between reflected and normal is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. Okay, right. So now the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, so incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. The bouncing back of the light from the reflecting surface is called reflection of light. The angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Okay. Now we can take, so the bouncing back of the light is known as reflection of light. Now laws of reflection. Okay, first point is, so incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. Second point is angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Once again, so incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. These are the laws of reflection. So here, sir, why you are saying these basics? So these are very basics, right? So based on this also they will ask question. So angle of incidence they will give, they will ask to find out angle of reflection. And sometimes explain about laws of reflection, so reflection of light. So these are all basics, but still they will ask in the exam. So make sure that you are preparing, right? So CBSE grade 10 physics. Now coming to the next one, laws of reflection completed. Next one, we can take angle of deviation. Angle of deviation is nothing but, so here angle of incident, so linear angle is 180 degrees. Linear angle is 180 degrees, right? So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus, here you can see, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence is equal to angle of reflection, right? Already we discussed here from laws of reflection. So we can write like this, that is angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence. So we can also write angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. So based on this one, they will ask one question based on this one. So angle of deviation, related to angle of deviation, they will ask one question. Okay, so be careful while writing this one. And here, loss of reflection and reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Loss of reflection and angle of deviation formula, angle of deviation. Okay, from angle of incident is equal to angle of reflection. From that we can take like this. Angle of deviation equal to 180 minus 2 angle of incident. Angle of deviation equal to 180 minus 2 angle of reflection. Okay, so now next one, we are going to discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular. So we'll discuss about regular reflection and irregular reflection. So where it will takes place, regular reflection and irregular reflection, and the remaining chapters we need to discuss. I'll explain. So already grade 11 topics are started, so it's going on. So vectors and scalars are explained, and motion in a straight line, projectile motion, motion in a plane, I explained that one. So here grade 11 topics already started. Grade 11. So actually units and dimensions, the topic I explained, and next one, motion in a straight line, motion in a plane. In that projectile I explained. So video is available in the channel. Just go and check. And grade 12 stone. So we'll start electric charges and fields. Okay. So we'll discuss that one. Now, so we are discussing about CBSE grade 10 physics, that is light reflection and diffraction chapter. Light reflection and diffraction chapter. Here now, regular reflection and irregular reflection we'll discuss. Regular reflection. So I'm taking the plane surface. This is a plane surface I'm taking. So incident light rays are parallel. Then reflector light rays are also parallel to each other. Incident light rays, these are the incident light rays. So incident light rays are parallel, then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. Incident light rays are parallel, then reflector light rays are also parallel to each other. So this is the incident beam. Okay, and so here this is a reflected beam. So light rays are parallel to each other. So incident light rays, so light rays are parallel to each other. So that's why that is called incident beam. Reflector light rays are also parallel to each other. So incident light rays are parallel, then reflector light rays are also parallel. So this type of reflection is called regular reflection. Coming to irregular reflection. So in irregular reflection, incident beam is parallel, but reflector light rays are not parallel to each other. Incident beam is parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. So I'm considering here irregular reflection. Okay, so here you can take irregular reflection. So incident beam is parallel, but reflector light rays are not parallel to each other. So incident beam is parallel. So here you can observe Incident beam is parallel, but reflector light rays are not parallel to each other. Reflector light rays. So this reflector light rays will move in different directions. Okay, so incident beam is parallel, but reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. Irregular reflection. So regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface, like you can say still water and your highly polished smooth surface. Coming to irregular reflection takes place on rough surface. Rough surface. Okay, so it takes place on rough surface. Example, plane or paper we can say, and wall we can say. So these are the examples: regular reflection and irregular reflection. I hope it is very clear. Coming to the object and image. Coming to the object and image, we'll discuss object and image. Okay, so object and image will discuss. Object and image. So are you ready? So object and image. Now you can see here. So I am taking the plane mirror. So here is the object. Here is the object. So from here, how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. How many light rays? Minimum 2 light rays are required to form the image of the object. Yes or no? Minimum 2 light rays are required to form the image of the object. So here I am considering one light ray I am taking like this. So after reflection it passes, and another light ray I am taking like this. After reflection, so those will move. If you are extending these light rays, if you are extending this light ray, image will form. This is the real object and virtual image. Real object and virtual image. Real object and virtual image. Here is a real object and virtual image. And one more I am taking here. Okay. So light rays are coming from infinity. Okay, light rays I am taking like this. After reflection, those light rays are meeting at one point here. So if you are extending the light rays, those light rays are meeting at one point here. You can see those light rays are meeting at one point here. I am taking this. See, virtual object and real image. Virtual object and real image. Virtual object and real image. Real image. Okay, virtual object and real image. So once again observe here. Once again observe carefully here. So real object. From this point light rays are coming. After incidenting, those are moving away from it. If you are extending this reflector light rays, extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their virtual image will form. Here you can observe directly reflector light rays are meeting. Directly reflector light rays are meeting at one point. Their real image. So we are extending the incident light rays. Extended incident light rays are meeting at one point. Extended incident light rays are meeting at one point. Their image is forming, that is virtual object. Real image and virtual object. Real image and virtual object. Real image and virtual object. I hope it is very clear to you all. I hope it is very clear to you all. So by seeing this one, we can conclude that By seeing this one, we can conclude that that is object is real. Object is real. Object and image. Object is real. Image is virtual. Object is virtual. Image is real. Okay, so by seeing these two diagrams, we can conclude that object is real, image is virtual, object is virtual, image is real, right? Yes. I hope it is very clear. Next one. Next, I am going to discuss about the nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. So plane mirror I am considering here. This is a plane mirror. So here object and image. Object I am taking here. So object height is AB. And how many light rays are required to form the image of the object? Can anyone say how many light rays are required to form the image of the object? Minimum 2 light rays. So that's why I'm taking 1 light ray here. And so one more light ray I'm taking like this. After reflection, those are moving away from it. One more light ray I'm taking here. It will be reflected back. Okay, so if you are extending these light rays, those light rays are moving. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Okay, so if you are extending here, the image will form here. Okay, A dash and B dash. A dash and B dash. So object is real, image is virtual. So in the previous example I discussed, object is real, image is virtual. Object is virtual, image is real. Point number 1. Point number 2. So the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Object distance is equal to image distance. And the next one, height of the object is equal to height of the image. Height of the object is equal to height of the image. And coming to the fourth one, fourth one is magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And the next one, it also shows lateral inversion. What is lateral inversion? Lateral inversion. So lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. So this mirror conversion is called this mirror image is called lateral inversion. Once again, the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Okay. Next one, once again we will discuss object is real. If object is real, image is virtual. Object is virtual, image is real. Object is equal to image distance. Height of the object is equal to height of the image. Magnification is +1. And also it shows lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. lateral inversion. I hope it is very clear. In the previous videos also, you can watch, you can observe my videos. So there are many videos related to light reflection and diffraction, human and colorful world, electricity and magnetic effects of electric current. So CBSE Grade-10 physics topics I discussed. So once go and check all those topics, right? Now, so we will discuss about spherical mirrors. Now we are going to discuss about spherical mirrors. Okay, the mirror which in the form of curved shape, that is called spherical mirror. Spherical mirrors are divided into two types: concave mirror and convex mirror, depending on the reflection of light. Chalo, then start discuss. Na 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 na. Na 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 na. Na 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 na. So there are spherical mirrors, two types of spherical mirrors: concave mirror and convex mirror. Concave mirror and convex mirror, depending on reflection of light. So two types of mirrors are there: concave mirror and convex mirror. So now, so part of this sphere, that is spherical mirror. Concave mirror is also known as converging mirror. So pole. So after reflection, light rays are moving towards the principal axis. After reflection, light rays are moving towards the principal axis. So this concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Whereas convex mirror is called diverging mirror. So you can see here. So after reflection, light rays are moving away from it. Like this. Okay. So concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror or diverging mirror. Okay, so concave mirror and convex mirror. Concave mirror is also known as converging mirror, whereas concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. Sir, why we are calling like this? So after reflection, light rays are moving towards the principal axis. That's why it is called concave mirror. So converging mirror. After reflection, light rays are moving away from the principal axis. That's why it is called diverging mirror. I hope it is very clear. Converging mirror and diverging mirror. Next one, we will discuss about terms related to spherical mirror. Shall we? Terms related to spherical mirror. Terms related to spherical mirror we'll discuss now. So I'm taking the concave mirror. Here is the concave mirror. It's a part of the sphere. This is a part of the sphere. This is center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. So I'm taking this a concave mirror. Concave mirror. Concave mirror. So the midpoint of the mirror is called pole. And center of curvature, the midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole. The line joining of center of curvature and pole is called. The line joining of center of curvature and pole is called principal axis. Principal axis. First one is pole. Second one is center of curvature. Third one is principal axis. Principal axis. Principal axis. And coming to the fourth one, the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. Radius of curvature. Coming to the fifth one, after reflection, light rays are meeting at one point. After reflection, light rays are meeting at one point on the principal axis, that is called focus. So we can also say principal focus. And coming to the sixth one, the distance between focus to pole. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Focal length. And coming to the seventh one, width of the mirror is called aperture. Width of the mirror is called aperture. Width of the mirror. Width of the mirror is called aperture. Once again we'll discuss. So here, these are the parts. Okay, so terms related to spherical mirror. Terms related to spherical mirror. So pole, midpoint of the mirror, center of curvature, center of the imaginary sphere in which mirror is a part. So the distance between center of curvature. So the line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called principal axis. The distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. So after reflection, all light rays will meet at one point of the principal axis, that is called principal focus or focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So the width of the mirror is called aperture. Width of the mirror is called aperture. So this is about terms related to spherical mirror. Terms related to spherical mirror. I hope it is very clear. Next one, ray rules. Ray rules we'll discuss. Ray rules. Shall we? Shall we discuss about ray rules? Right? Next one, we will discuss about terms related to spherical mirror. terms related to spherical, already completed terms related. Ray rules will discuss. Ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. Ray rules. Ray rules of concave mirror. Concave mirror and convex mirror. Convex mirror. Convex mirror. Okay. So ray rules of concave mirror and convex mirror will discuss. Now, first one is concave mirror. Concave mirror, converging mirror, convex mirror, diverging mirror, concave mirror, converging mirror. Pole, focus, center of curvature. Light ray is coming from infinity after reflection passes through focus. One light ray I am taking like this after reflection passes through focus. The second light ray pole, focus, center of curvature. Light is passing through center of curvature after reflection moving towards infinity. Coming to the third one. Pole, focus, center of curvature. Light rays passing through center of curvature. It retraces its original path. Coming to the fourth one. So here is the pole, focus, center of curvature, light rays incidenting, so it will be reflected back. So coming to the convex mirror. Convex mirror. Convex mirror. So first one is convex mirror. Pole, focus, center of curvature, light rays coming from infinity after reflection passes through. So it passes through focus. Coming to the second one. Pole, focus, center of curvature, light rays passing through focus after reflection passes towards infinity. Coming to third one. Light rays passing through center of curvature. Center of curvature. It reflects back into the same path as we discussed for concave mirror. For convex mirror also same thing. Fourth one. Light rays incidenting at the pole. Pole, focus, center of curvature. Light rays incident at the pole, it reflect back. Yes or no? So this is about concave mirror and convex mirror. Concave mirror ray rules and convex mirror ray rules. Next one we'll discuss about image formation. Image formation by concave mirror and convex mirror. Sir, why you are saying all these points? So directly we can express formula problems like this. So concept is very important. Concept is very important. Daily classes will be there related to CBSE Grade-10 physics. Okay, and even grade 11 students. So those classes also available. So live classes grade 11 and grade 12 also. For grade 12 students also class are going on. So we'll start. Grade 11 already started. So grade 12 also will start soon. Right now. I hope it is very clear. So ray rules of concave mirror and convex mirror. Next one, image formations. Image formations. Image formations. Image formation. Image formation. Image formation. Image formations. Image formations. Now start discuss. Image formations of concave mirror and convex mirror. Image formations of concave mirror and convex mirror. Image formation by concave mirror. Okay, so we'll take small break. After that, we'll continue. So thank you for joining and attending the class. So we'll see. So we'll take small break. Ready? So thank you.